get us started, we know that this is going to be the layout following the road, right, for all our sanitary pipes. And over here, it was kind of hard to see, but these kind of oval shapes, and you can see this is a 510 feet, 508 feet contour line. This is kind of the top of the hill, this MH6. Now there were also some lots here at the beginning, 18, 19, 20, and 29, and we couldn't just gravity feed those into MH6 because they're, we don't have much elevation, as we'll see in a bit. So what was decided for these was that they would, those 4 lots would have individual grinder pumps located on their basements, and that sewage would be pumped into MH6. So we made the assumptions, we didn't actually put them in place with the pumps and everything for simplicity. If we look, and I will look at the flow just for a minute, what I'm showing you here is the flow in gallons per minute. So the beginning of the line here only has 6 gallons per minute, whereas here we're seeing 63, which is taking into account the potential peak flow of all 4 pumps being on at the same time. But this other place here has a flow of 5 gallons per minute. So you can see that we're dealing with low flows and also not a whole lot of elevation change. So this contour line is 506 feet here, and we know that we cannot change the elevation of the outfall because this represents our connecting point to the existing sewer. So we will not be able to modify the invert elevation of 490. Okay, so with that information and with the layout, we start with our base scenario, which looks like this. Where did my profile go? There it is. Okay, so I'm going to open this up. Again, the profile that I'm showing at this moment, I'm going to highlight it here. This is before we do any design. So this was very first try. We put some pipes in place, 12-inch diameter pipes, as you can see here, and we laid out our initial slopes. So let's see what that was, and the calculated velocities. So given those flows and the slopes, we have velocities of 0.95 feet per second, 1.1, 1.91. So we're going to struggle with meeting the velocity at this pipe CO1 and CO8, as we can see here, because the flow is just so small. And you might want to play with the slope a little bit, increasing the slope in an effort to improve that velocity. But we started here, and so we didn't really like the velocities there, but we tried our first design and we said, okay, let's see how much better can SewerCAD do with this. And for this initial design, remember that we made some assumptions. Again, we said to not modify that outlet 1 invert elevation, but to define the pipe diameter. That's what design conduit means. And to modify the invert for the upstream manhole and the downstream, with the exception of that one. Okay, and how is SewerCAD going to do it? Well, by keeping a velocity minimum of 0. So at first we put no constraint on the velocity, only the maximum that should be less than 15. Minimum 3 feet cover. So this is important, this value here, maximum 15, and we input a slope of 0.003. So remember these two values, minimum cover of 3 feet and minimum slope. Okay, and we run it. And so now let's look at the results. The first, so let's go back to the profile that we had. Okay, so I'm gonna switch live. So remember, this is where we started. Okay, and this design looks pretty smooth with the slope and everything, but there's a potential problem here, or something that you might want to fix, and it's that you're excavating quite a bit. And in this point here, which is our MH3, the ground elevation is 506 and the invert is 496. So there's 10 feet of cover, and we're always trying to minimize our excavation costs again, so that could have been improved. If I also did a profile, just so we're aware, from here, let's do it all the way to here. I'm going to show you. This is manhole 6. So we're going to keep an eye on both profiles. So again, this is what we're seeing here, that 0.03 slope. Okay, so that's where we started. All right, so we then said, let's see what results we get with our original design, where we say 0 velocity and 0.003 slope. So look at what SewerCAD did. At the very beginning, well, first of all, it looked at the flows and it decided that 12-inch diameter wasn't necessary, that 8-inch would be enough. And if you remember, when we set our catalogs for the pipes, remember that we said it has to be at least 8-inch. We said do not pick 6, do not pick 4, didn't make those available. So it decided that 8-inch would have been enough. I don't have the color coding, or let me show you here. We can see here that it is 8-inch for this design. I'm just going to move back to the other one. Did not have a color coding on the pipe size, but you see that all of them were 12-inch and now they're 8-inch. And we could do flex table as well if we wanted to, but actually let's do that so you don't have to take my word for it. You can actually see the results. So they were originally 12-inch, as you see here in our base, and in the first design they've all been modified to 8-inch. Okay, so that was the first thing that it did. It said the diameter 8 is good, and then it's stuck here. Notice that it goes from 502 to 505. So it's sticking to that minimum 3 feet of cover to save you money on your excavation costs. And remember also, what was our slope? We said minimum slope has to be 0.003. So it also used that minimum slope so that you didn't have to dig so much to put those pipes in place, right? So again, trying to save costs. So it sticks to that 0.003 slope, as we see here. And then it said, okay, in order to get to that 01, which could not be modified at 490, then the last pipe has a big slope. Okay, so that's interesting that it did that. And look what it did for the others. So where it had to meet that connecting point at MH3, it did that. So it also stuck to the minimum cover and minimum, well, not minimum slope there, because it kind of, it's a very steep ground, so it kind of followed the ground in that area. Okay. All right, but one thing we did not like about this is the velocities. So 0.76, 0.9, and we said what can we do to improve those velocities? Well, we're going to change our criteria. And then we did a second design run, and we say, okay, what if I now ask for a minimum velocity of 1? So let's go back to our alternatives, and we'll review what we changed. So here we're now requesting minimum velocity of 1. Cover is still 3, and we did change the slope, did we not? Yeah, the slope was 0.75. Okay. And I'm not going to run it because I had already run it, but that's basically the two changes that we made. And then we said, okay, let's go back and compare our designs. Profile 1. So this is with the velocity of 0, and now with the velocity of 1, you came up with this design. So let's keep an eye on what it did. Again, for the very first one, sticks to the minimum cover, and then the minimum slope, which is 0.0075, which does improve the velocity a little bit. So you can see velocity is 1.06, 1.25. So velocities are better everywhere, and in this one, CO8, now it meets that criteria of velocity equals 1. If you run this, you notice that there was a message about this conduit 5 not being able to meet the 0.0075 slope, because literally there is no more room given the constraint here with 490 feet elevation for this invert. Okay, so you might say, okay, which is a better design? Well, if you really want to stick to the velocity and you can't, and that is your design flow, then you'd have to go through with this one. But keep in mind that your excavation costs are going to increase by quite a bit because you are changing that slope. All right, so basically that was what we're being asked here. What was the original diameter? What diameter it picked? We looked at the slope. We saw how the velocities improved. And now let's see the explanation for the questions. Did we have adequate velocities in the system in the initial design? Meaning this one, the design one. No, because we have 0.76 and 0.1. So when the slope was flatter, the velocities were lower. What size pipe did you end up with? 8-inch minimum, because it was enough to carry all the sanitary flows. You can see that there's plenty of capacity. In fact, we could go back to the flex tables and look at the capacity. So there's different ways of doing it, but we've been doing depth over rise, so let's stick with that. And it's not there, so I'm just going to pull it from here. Okay, so you can see that there's plenty of capacity. I'm going to sort it descending. So they're flowing at like a third full, so 35% full. Plenty of capacity even with an 8-inch pipe. It didn't pick anything less than that, 6-inch or anything, because we did not make those available for design. Third question is, what other way could you have served the 4 homes on the other side of the drainage divide? You could have had them connect perhaps to the manhole 8 if they were connecting on the right side, but then going through people's properties, not as simple. Or you could have collect via gravity at a low point and then pump to MH6 instead of individual grinded pumps at each home. And what would you prefer, the original invert elevations or the values that we got from the designs? And the solution here is a decision between how much it's going to cost to excavate versus the velocities. Okay, and the final question, what else can we do about the low velocities in pipes CO1 and CO8? Because the flow, again, is only 6 gallons per minute and 5 gallons per minute here, you don't really have very many choices. This is common, as we had talked earlier, for the upper end of the collection systems. Yeah, really at that point all you can do is try to change the slopes as much as possible for those main parts or the beginning of the run, because you couldn't really minimize the diameter anymore. 8 inches was as low as you could go. All right, and there you have it. This is how SewerCAD can help you improve on your.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.